A very good morning to my lovely panelists. I am Awan bin Taib, I am Nikmat bin Ibu, and my fellow friends. My name is Lim Sei Fen with student ID AA20219. Today I am delighted to present my final year project with the research topic on unlocking the potential of building information modeling BIM in Malaysian construction project management, barriers and best practice. Firstly, let me provide an overview of the presentation outline. I will begin by introducing the research background and highlighting the problem statement derived from the relevant articles I have reviewed. Following that, I will outline the research objective, research questions, and the scope of the study. Next, a summary of the literature review will be presented, followed by an introduction to the research methodology employed. Furthermore, result and discussion will be analyzed, and lastly, I will conclude my research and provide some recommendation with the reference used in this research presentation. Firstly, let me provide you with a brief introduction to the key aspect of BIM. The construction project management in Malaysia is a significant economic driver which contributing 3 to 5% to the country's gross domestic product (GDP). According to Dawn 2019, BIM offers a transformative approach to construction project management by enabling cooperation and sustainability. It provides a shared platform that encompasses all relevant project information, including components and activities. Besides that, the Public Works Department's PWD recognized the potential of BIM and introduced it in 2007 as a means to achieve cost saving, enhance project scheduling, and ensure overall project quality. The department has set a goal to implement BIM on 10% of public construction projects with a budget exceeding 50 million ringgit Malaysia in the 11 Malaysia Plan. Let's come into the problem statement that underlines this research. First, despite the effort of the CIDB in Malaysia to promote BIM and enhance construction practices, the industry is still heavily relying on traditional processes. Furthermore, research conducted by Memon indicated that while BIM implementation in Malaysia is deemed satisfactory during the design phase, it lacked effectiveness during the construction phase. Third, the utilization of BIM in construction project management remained limited in both private and public sector. Shockingly, only 13% of organizations in Malaysia currently employ BIM. This low adoption rate raises concern about the industry's progress in harnessing the benefits and potential of BIM for improved project outcomes. The last problem statement involves evaluating the use of IT in project development, management, and legal compliance to assist the construction community throughout the entire facility lifecycle. These technical issues are one of the concerns. Now, let's move on to the research objective and research questions that will guide the investigations throughout my research. The two objectives of this study is to identify the key barriers and to determine the best practices on the adoption of BIM in project management in Malaysia. To achieve these two objectives, we have formulated research questions to guide our study, which are what are the key barriers and how can we determine the best practices on the adoption of BIM in project management in Malaysia? It is important to note that the scope of our study, we will specifically target project with a registration grade of CIDB license above G5, where the project cost does not exceed 5 million ringgit Malaysia. Additionally, we will focus on conducting questionnaire survey of various stakeholders involved in BIM implementation. Based on my study from different articles, the literature review highlights several key barriers to the adoption of BIM. Let's summarize the findings from various studies. These barriers encompasses financial, technical, skill, community, social, people organization, and motivation that hinder the widespread adoption of BIM in project management. Other than that, from the research from 2016 to 2022, we identified the sub-factor for each key barriers as the table shown. Next, the research methodology for this study involved the following approach and procedures. Firstly, this study adopts a quantitative approach to collect and analyze data by statistical technique. By using representative samples with large sample size, the research aims to provide comprehensive insight into the entire population. The primary method of data collection is through a questionnaire survey. The survey consists of demographic and pairwise questions. This method allows for the standardized, direct, and easy collection of data from participants involved in the research process. The sampling procedure involves the use of stratified sampling. The population of respondents are divided into two groups based on their adoption of BIM. We call it strata. And then a random selection from each stratum is made. This study mainly uses the MyBIM website is identify the target participants. This sampling approach ensures that each company within each group has an equal opportunity to be included in the sample as well. The target population for the survey include all construction firms operating in Malaysia with either a CIDB license registration grade of G5 or higher or a MyBin Center member. Hence, it has targeted 74 participants involved in this research. In addition, the respondents will consist of a diverse range of stakeholders, including project managers, architects, engineers, contractors, and other relevant professionals. To approach the targeted respondents, the completed survey form will be distributed through various online platforms such as email, company website, LinkedIn, WhatsApp, or cold calling. For data analysis, the analytical hierarchy process AHP will be used. AHP is chosen due to its ability to generate higher quality result and assessing multiple factors while using a single step. Next, the flowchart illustrates the research process, starting with the literature review to identify objectives and design the questionnaire until the ending. The finding will be discussed and a conclusion will be drawn. A conceptual framework for AHP has been developed to achieve the first objective. The framework consists of three layers. The first level represents the barriers of BIM adoption. The second level identifies the factors contributing to these barriers, including finance, financial, technical skill, community or social motivation, and people organizations. The third level further elaborate on sub-factors to support each sector. As mentioned earlier, this result will be analyzed as two parts, which are demographic and pairwise questions. Out of the total 32 respondents, the majority are male, constituting around 72% of the sample. The research involved different working states of respondents in which the urban areas are the most involved, such as KL at individual, Johor 7, and Selangor 5. Next, the figures show the working sector of respondents. The largest portion of respondents is from the private sector with 93.75%. The data revealed that a substantial number of respondents, totaling 65.63% of the respondents' company, holds a CIDB license grade above G5 considered certified in the result. Next, this figure illustrates the distribution across respondents' various working departments. The largest portion fall under the construction department with 9 respondents, while engineering and consultant CNS departments closely follow. Moreover, based on the professional nature of the construction industry, where a bachelor degree is often a standard requirement. In this figure, the majority constituting 14 respondents has accumulated 1 to 3 years of experience and 9 respondents have more than 10 years of experience. The distribution across other experience brackets capture insight from both career professionals and those with more intensive industrial exposure. Among the respondents, more than half use BIM in their work, but only 25% said that they frequently use BIM. A significant portion of respondents underscore the necessity to bridge the gap between awareness and practical implementation in BIM adoption. For the experience and knowledge of BIM, most of the respondents, which is 10, identify as having intermediate knowledge. However, only 6 individuals consider themselves advanced and expert in BIM. Lastly, the distribution of respondents based on their agreement on the benefits of BIM to their work is presented. The findings from the survey shows that the presenter has a good attitude toward the benefit of BIM due to none of the participants expressing disagreement with BIM positive impact on their work. Moving on to the next phase of analysis. The pairwise question has been evaluated using the AHP, and the parity vector of the factor and subfactor is presented in this chart. The most significant key barriers identified is financial, which is at 32%, followed by technical skill at 28%, while the least significant barriers are motivation and community socials, both at 12%. Next, the global weight of subfactors are assessed. As depicted in the figure, the three most prominent subfactors are high initial cost, lack of experience, and high training costs. This model shows the best practice for the identified barriers on the adoption of BIM. To address the issue of high initial cost, it is suggested for government assistance and incentives, such as tax breaks, subsidies, or grants, and long-term cost-benefit analysis is needed. To deal with the lack of experience, organizations should cooperate with experienced BIM implementation firms. These cooperations promotes exchange of information by allowing employees to learn from seasoned experts and improve their BIM implementation skills. In order to address the issue of high training costs, it is advised that contractors investigate cost-effective BIM approach such as pay-per-use or priority licensing. In conclusion, the two objectives to identify key barriers and determine best practice for BIM adoption in project management in Malaysia have been successfully achieved. For Objective 1, 18 crucial subfactors are categorized into 5 significant barriers factors. In Objective 2, the best practices such as government support, company cooperation, knowledge exchange, and exploring cost-effective BIM concepts are identified as effective solutions for addressing the identified barriers. Here is some recommendation for future study. It should be a broader representation of construction project management skills. Expanding BIM user engagement is crucial for obtaining a diverse industrial perspective. Longitudinal studies are needed to assess the long-term effectiveness of recommended best practices. Lastly, a comparative examination of BIM adoption in Malaysia and other countries can offer valuable insight. Now, here is some list of reference used in preparing these presentations. That's all for my presentation. Thank you.